Hi everyone. This is an example of a mass-to-mass stoichiometry problem. Here we go. A 14.87 gram piece of zinc is placed into a solution of phosphoric acid. After the reaction stops, 8.26 grams of zinc remains unreacted. What mass of gas was produced? We need to look for some keywords to figure out what the reaction was and balance it. Then we need to interpret what's going on in the question. The zinc was placed into phosphoric acid, and we have the expectation that some type of gas was produced. So we have zinc reacting with phosphoric acid. Zinc is a metal, Zn. Phosphoric acid, we can look it up on the acid table in the data booklet. It's H3PO4. This is a single replacement reaction where the two cations replace each other. The zinc and the hydrogen switch spots. The hydrogen gets kicked out alone. Oh, hydrogen is H2. And the zinc, which is a 2 plus, gets together with the PO4, which is a 3 minus. Now, we need to balance this reaction. We end up with 3 zincs on either side, 6 hydrogens, 2 times 3, 6, 6 hydrogens on either side, and 2 phosphates, 2 PO4s on either side. We have a balanced chemical reaction. Let's look at the interpretation. A 14.87 gram piece of zinc. That's the mass of the zinc. That zinc was placed into a solution of phosphoric acid. There was a reaction. Here it is. When the reaction stopped, 8.26 grams of zinc remained. So I'm putting a small one in. The initial mass of the zinc was 14.87. The final mass of zinc was 8.26 grams. There's something going on there that we have to talk about. What mass of gas was unreacted? Pardon me, what mass of gas was produced? Produced means it's on the right-hand side of the arrow. Which one is the gas? The zinc phosphate or the hydrogen? The periodic table shows me that hydrogen is the gas. So this says, what mass of gas was produced? It's an indirect way of saying, what's the mass of that hydrogen? And if we're looking for it, it's required. Clearly the zinc over here is going to be the given, but there's something special going on. We have the mass before the reaction, we have the mass after the reaction stops. But what we care about is how much zinc actually participated in the reaction. Because of that, we have a little bit of subtraction to get into before we even start. So we have, what's the difference here? We started with 1487, 8.26 was left over. It means that when we do the subtraction, I'm going to write it like this, delta M. The change in mass was 6.61 grams. That's how much zinc actually reacted. This is a special kind of situation. Not only is the chemical that we're solving for left a little ambiguous, we need to make a decision. We have 2 masses that both go with the same chemical. It's not unheard of to encounter this type of scenario. So we had to do a little bit of subtraction to find the change in mass. And that's how much actually participated in the reaction. It's that change in mass that we're going to use for our calculation. Lots of interpretation here in this question. But after we have that, our next step, find moles. Clearly the question here did not tell us the moles. We must do mass over molar mass using this 6.61. 6.61 grams. That's the mass of zinc. And the molar mass of zinc, I'm double checking, it's got to be 65.41, which it is, over 65.41 grams per mole. Because that's the mass of zinc, we use the molar mass of zinc, 65.41. Our next step, multiply by R over G. R, the hydrogen, is the gas that we're searching for, 3 over 3. All of that represents what we've been calling red N. And to find the mass, in the end, it's this red N multiplied by molar mass. However, we use the molar mass of the zinc initially, but now because we're on the right-hand side after the R over G, to find the mass of the hydrogen gas, we must use the molar mass of the hydrogen, which is 2.02 grams per mole. We have some buttons to push. 6.61 over 65.41 times 3 over 3 times 2.02. This equals 0.204130867. And when we express that with 3 significant digits in the question, or the 6.61 that we used likewise had 3 significant digits, 0.204, and we found the mass grams. It's not unheard of for us to have the chemical that we're solving for be a little bit ambiguous. What was the precipitate? What mass of gas, like we had here? An added wrinkle is we had an initial and a final mass of one of the reactants. So we had to do a little bit of subtraction to find the change, and that's what we used in our calculation itself. We still followed our same 4 steps, only we had extra emphasis on the interpretation part of this question. And I hope that helps.